Hey y'all, welcome back to my channel. I'm Cyrus and this is Cyrus Codes, where we talk about engineering, engineering management, career path, and life advice for engineers, tips and tricks, all sorts of different things. But today, we're going to talk about the biggest mistake I've made in my career. Now, this is a story of me not only taking down my company's entire website, app, and product, but also in the same swing, taking down another company's app, website, and product. So buckle in, it's going to be exciting, it's going to be chaotic, and I might sweat a bit because even thinking about it definitely makes me nervous. So, in order to set the stage a little bit, it's the fall, it's September or October in 2014. This was the first project that I was ever leading, and it was for me pretty high stakes. It was also a big release for the company. We had press going on around it, we were marketing it to all of our customers, 250,000 of them at the time, and so I felt like a lot of weight was on my shoulders. I'd prepared a bunch for it with myself and the team of us that worked on this particular feature. We thought we were ready, we were feeling good, but everything went to shit. So here are the products involved. We've got my team and my company, it's called Betterment, we're an online financial advisor, and we were integrating with a company who we'll call Zoomy. Now, this was the first time as a company and as a product we built a feature that deeply involved in integration with another company. And in particular, this will come up later, an HTTP API, a kind of web-based integration with another company. At the same time, we were turning around and marketing this feature to 250,000 customers. We had press coming on at 9 a.m. and that's where the story starts. So 9 a.m. rolls around and the first press piece hits. We're looking at all of our gauges and our dashboards and we see traffic numbers going up and to the right. We've got new customers visiting the site. We've got existing customers who just received an email pitching them and telling them to come on in and try this new feature. Now what this new feature was the ability for customers to connect all of their other financial accounts besides the accounts that they have at Betterment and get advice across all of them. And in order to provide that functionality, we were working with Zoomy, who would take our customers' login information for their different financial accounts and give us data back about the balances that they have there, etc., so that we can give a more integrated advice experience. Now those details aside, we're going to talk a lot about Zoomy, we're going to talk a lot about Betterment. It's 9 a.m., the first press hit comes out, and people are coming in the front door. Now, at around 9:05, we get our first alert. And this alert basically says, hey, there's an elevated error rate in your web tier of servers. So the servers that are receiving requests from customers who are using the app. That error is something that we experienced sometimes, fairly regularly, right? Sometimes it means that a certain category of customers is having a bad time, or maybe it means that a certain kind of failure happened repeatedly. Think maybe a customer is refreshing the page on a failed request or refreshing the page really rapidly on a page that is broken for them right now. And so it's not always a red alert, but it's always something that the on-call engineer is going to look at, and especially so when we're in the middle of a big launch. Now, immediately after that alert comes in, we get the real red alert. The real red alert basically tells us, hey, you're having a bad time serving requests, at least an 80% failure rate of all requests that you're receiving in your web tier of servers. So what does this mean? It means 80% of the time that a customer is clicking a link in the app or trying to log in to our app, it's failing, straight up. Not a good situation to be in, not a good situation to be in on launch day, especially 5 minutes after launching. So I immediately spring into action mode. I'm trying to figure out what's wrong. Our infrastructure team then tells us, hey, not only are requests failing, but we're also seeing that all of our web tier servers are pegged at 100% CPU. Now what that really means is basically that these servers are working as hard as they possibly can, and they're not receiving any new requests. So that explains why we were seeing an elevated failure rate. Basically our servers were just way too busy to respond to requests that were coming in. So that's not good. We've got a huge failure rate, we've got our servers basically being completely preoccupied with something, and that's when our phone rings and it's a call from Zoomy. pick up the phone and talk to Zoomy, and they tell us that their entire website was unavailable. They had not only an 80% error rate, they had a 100% error rate, and their entire website, app, and API was completely unresponsive. Again, not good, but we hadn't immediately stitched together the fact that these two things were completely interrelated. When we saw the 100% CPU and we heard that they were experiencing a dramatically elevated rate of web requests and that had taken their service down, we immediately dug into the code and asked ourselves the question, is there anywhere that we are basically rapidly making requests to Zoomy that is not only causing an elevated rate of requests, because we thought to ourselves, well, we might just have a popular launch, right? Maybe it's their fault. But is there a place where we're making requests repeatedly in a way that's completely irresponsible? In a way that to them basically presents as a DDoS, a distributed denial of service attack, at least distributed across all of the servers in our web tier. So we dug into the code and we tried to figure out where could this possibly be happening. Now this is where I'm going to get into the details a little bit, but the easiest way to think about it is that part of our integration with Zoomy is polling them for information. So that basically means is when we're performing some operation, we need to make a request to an endpoint of theirs and ask, is that operation completed yet? Usually the reason why a service will do this is because the operation they're performing on your behalf is pretty long running or expensive, longer running than you would ever want an individual HTTP request to be. So we're looking at the code where we need to poll, waiting on the result of, in this case, authentication for a customer's some external financial account that they have. And what we find is that this code is basically saying, if the operation isn't done, make a new HTTP request in a tight loop. It's a little bit more subtle than that because it turned out that the way they communicated to us that we needed to poll again was not by giving us an HTTP 200 or a successful response and saying, hey, here's some data that tells you that you need to ask us again and you can go ahead and ask us again soon. Instead, they would return an exception, which caused us to catch that exception and then decide to retry. Now, if you've been in engineering for a while, you might see where this is going, but if not, this is where it gets really, really detailed. It turned out that the exceptions that we were catching and retrying were not limited to the specific kind of exception that is thrown when we need to perform more polling, but we were actually catching every type of HTTP exception. So in essence, what was going on was we were asking them, hey, what's the status of that operation? And they were like, 503, error code, our servers are completely unavailable. And we were like, what's the status of that operation though? So bad. So we found this piece of code, we let them know that we found the error on our side, and we immediately got to deploying some kind of fix. Now, we got really lucky because what we needed to do, what you might already realize we needed to do, is move something like this into a background job. You never want your web tier servers to be responsible for polling an HTTP service because it can fail and you want to be able to have automatic retries. And if something like this happens, a cascading failure, you want your servers that are handling web requests to be totally insulated from it. Hindsight's 2020. We set out to make this change. We were able to deploy a change within 20 or 25 minutes that put a band-aid on the solution, and then we were able to, within an hour, really solve it appropriately. This meant that all of the PR, the news articles, the press hits that were coming out were able to kind of go off without a hitch, mostly, and all of our customers who had received emails announcing this new feature were actually able to use the app. Most importantly, all the customers who wanted to use the app for reasons that had nothing to do with this feature were able to actually use it, which wasn't the case when our entire web tier was pegged at 100% CPU. Coming out of all of this, there are a bunch of lessons learned. I want to go through each of them and just kind of give you some tips and context so that you don't make the same mistake that I made and that my team made that day. There are things ranging from the actual software development process, how to make sure a change like this or a code like this never reaches production in the first place, how to architect things like this that are making HTTP requests to external services like Zoomy, and ways that you can de-risk deploying new features in general, things that you're launching that you have confidence in, that you've tested appropriately, but that can behave in totally unpredictable ways when the rubber meets the road of production. First things first, let's talk about how a change like this actually ever made it to production. This, I think, is the kind of biggest failure of the whole process, because our team within the company was able to make this change, deploy this code, test it against against Zoomy's test servers, and everything worked totally fine. But we never actually reached out to the broader engineering team and did anything like a design review, an architecture diagram, asked for feedback from some of the more senior engineers at the time. We never did any of this. We were the first team that was building a feature that had an integration over HTTP with some company for some reason, and we didn't think to build some consensus around the patterns and the appropriate architectural model for doing something like this for real and at scale in a way that's embedded totally deeply within the product. If we had done that, the idea of moving this work, this polling to Zoomy to see if the operation was complete into a background job would have been totally obvious. At least 4 or 5 people would have told us to do that. The second thing is knowing when to use your background job queue. Now, it turns out that basically 95% of the time when you're doing an HTTP interaction, when you're making calls to some external service, their API, for example, you want to try as hard as you can to do that in some kind of background task or background job queue. If your platform's Ruby, maybe that's Sidekick or delayed job. In Python, maybe it's Celery. The idea of these background job or asynchronous task queues is that, number one, you don't have your web tier preoccupied doing HTTP requests, and number two, if they fail, which HTTP requests are totally prone to, they can easily be retried. Lastly, the thing that's really nice about them is that if you have entire kind of categoric failure the way that we did, you can easily pause or delete the jobs that are in the queue. In our case, with our servers pegged at 100%, rebooting them didn't help at all because they immediately started going back into that infinite loop of cascading failure. When you're in this situation, having your background task queue be preoccupied means that if you have customers coming in who want to do something else that has nothing to do with this particular kind of category of HTTP interaction, or if you have customers that come in and want to do something that has nothing to do with your feature that uses HTTP APIs, they totally can, right? So use your background job queue for as much as you possibly can. It'll keep your web servers snappy, and you'll get some retry and resilience basically for free. Lastly, I'd encourage everyone to use feature flags or feature toggles when they're launching something new. In our case, if we had a feature flag in place, completely independently of a deployment, we could have flipped the feature off, all of our servers could have been rebooted and come back to life totally healthy, Zoomy would have been able to reboot their servers and come back to life totally healthy, and we would have had safe space and time to fix the feature without interrupting our customers who wanted to do other things with our app. So having feature toggles and having feature flags is really just an easy way to have insurance, no matter how much you've tested your new feature or your new product in development and in staging. We, for example, had a fully fledged staging environment and things were working great, right? So you can basically use this as a form of insurance against the unpredictability of having real features in production. And lastly, I think this is super important. Whenever you're launching a new feature, and especially when you're launching a new feature that's a partnership with another team, or another product, or a new API, always make sure that you've done a ton of testing in production and that you have them easily accessible during your launch. We were lucky in that we had opened up a war room and had clear lines of communication with Zoomy for this launch, but we didn't do a lot of production testing. We used a staging environment heavily, and that obviously didn't represent the true variety of failure modes and volume that we were going to see in production. do some load testing, do some production testing, do whatever you need to do to get really confident that when you do your launch, your partner and your own application is going to be ready to handle whatever comes at you. I hope you enjoyed this story. For me, it's a ton of fun to tell. I end up telling it a lot, especially when people come to me maybe down about a mistake they made or some small error. I always use it to just kind of reframe the scenario and let them know that yes, they made a mistake and yes, it wasn't good, but also bigger mistakes have been made more publicly, more catastrophically, not just for us and our company, but for others too. If you like this story, go ahead and give a subscribe or give a like. Leave a comment down below if there's something I did that was totally dumb that you noticed that I didn't mention, or if you really like the video and you want me to do more like this. Thanks so much for watching, and I hope I see you soon.